Hello back. I could get someone interested in a combination of these two machines. So that means that's the beer machine, you know very well. That is the peristaltic pump that you might know from earlier. What I'm building now is combining these two into a system that fills liquid into bottles. I can't tell you much more about what liquid in details, but I certainly can tell you a few things about the general technology. This is the peristaltic pump I had made with the skateboard motor down here, and that seems to work pretty well. And now I modified it a bit, because originally I had these distributor tubes, because this is a twin peristaltic pump. It had two hoses in here, which has the advantage that if you have two peristaltic pumps that are offset by a certain angle, that makes that you have less pulsations. And here you also have the nice symmetrical layout. You can see with the belt in the middle and the hoses left and right and the bearings left and right. It's all symmetrical, which mechanically is nice. And that was the one I had for the foam pump. I was building for the foam pump, and I had this collector tube here to collect from these two hoses into one major hose. But since I need to combine it all with this here, I switched to this hose here that I had gotten for this one originally before I switched back to a smaller diameter, you might remember. And so I'm trying to run the peristaltic pump with this more or less standard silicone hose and not the very special, fancy, expensive and hard to get peristaltic pump hose that I originally had. It's that stuff here. It's that white hose, which is FDA approved and has lots of certifications, but there's only one manufacturer worldwide producing this, so you can imagine how it is about availability and especially about prices. So I don't want that. I want to switch to something I can get from multiple sources, and that also then has the right diameter to go into that. And then I can just make it all with the same hose, which is the better way to do it. Now, to switch out the hose in a peristaltic pump is usually a bit an uncomfortable process, because you are squeezing the tube, right? So as long as you're squeezing the tube, it's difficult to get it out. But there is one trick you can use, and the trick is very easy. The thing is, since the peristaltic pump is rotating and squeezing the hose around like this, it will have a tendency to pull the hose in. And that means that once you have it installed, you need to hold it at the end, because the pump will always a bit be pulling on that hose. But on the other hand, you can use that pulling to pull the hose in, right? And one improvement I made instead of that collector tube is that you see here I have printed a part that does a bend, and I have this T-piece, so if I put it like that, I don't need the collector tube, because printing watertight tubes is a bit tricky. So that's why I prefer to use that standard part I got. And so now that means I can pull in these two hoses, and I'd like to show you how I do it. It's not going to be trivial because it's the two hoses in power in the same time, but let's see what goes. So first we need to rotate. Okay, wrong direction for sure. So that's the wrong direction first. So we need to switch the direction. Where was it? This is the directional switch. Switch it over. Try again. Yeah, now it pulls in the right direction. And now I can just... Actually, I need to put first this one in. See, now it pulls it in. Ooh, actually, that answers also my question about the motor power. I think I'm slightly limited regarding the motor power. But let me see, now everything fits as it was supposed to. And now I can put a clamp up here and a clamp down here that will hold this hose, and I put a clamp over this here to hold this hose over there, and that should do the trick. Let's try that. My trusted electric screwdriver, since I know there's gonna be many turns, I start electric straight off. So, up. Oh, I lost my nut. Look what happened down here. See the nut? It fell out instead of getting caught in the 3D printed hexagon. This is bad. Try to fix that somehow. Come on! That nut is not cooperating. So, it is all together and it pumps. Let me show you. Okay, now. So, as you can see down here, it is now all properly in. That clamp with the bent, the T-piece in between. That looks all pretty good. I'm pretty happy with how this came out. And now comes the moment where I can turn on the power. It pumped. That's right, you see? It works, it does something. There's liquid coming out down here. But there's one thing that preoccupies me. If you look up here, you see how this moves down here? You see how this gap opens and closes all the time? I'm not sure if you see it moving. Yeah, you can see it moving. The reason why it is moving is that the original hose I had has a thinner wall thickness than the new one I have here. So, autofocus, please. So you see, that has more wall thickness than that one. Even if that one has the smaller diameter than that one, what's interesting in a peristaltic pump is what happens if you compress it like this. And you see, that one is wider than that one. So, and that makes that I'm very highly compressing the motor. That's why the motor is struggling. You saw it had difficulties starting up because I'm just wasting torque needing that rubber, which I don't want. Now, how do I fix that? That's the rotor. That's the second rotor I had because it was a dual setup. You might remember mixing foam and stuff. So that rotor needs to be reprinted once again with these ones slightly further inside. I think I'll go for 1 millimeter or so. Then I'm taking all that thing apart again, which is good because I realized I have some nice little parts printed to go to make the outlet here, but you don't get them in unless you take everything apart. Yeah, assembling stuff is always easier in theory than in practice. But so I will have to take the whole thing apart. I will have to redesign that rotor for the other hose and reprint it, and then I can go. But I'm still happy that at least I can pump some water for now, and I'm getting step by step closer to the goal of having that thing and that thing work together. The next challenge will be from this mainboard, which I want to keep, to go down onto this motor controller down here. And I already have this adapter board in here, this one, which basically is optically isolated on this side and has power MOSFETs on the other. And I'll use that for two things. Actually, I need only 3 of the 4 channels, but you know how cheap these things become on AliExpress. So I need one channel to turn the fan on and off. You hear that fan? It's that cooling fan I have here blowing air into my motor. Since my power density of the motor is rather high, I need a good cooling there. But I don't want to run that fan as soon as the power goes on, like now. Now I have 24 volts and the fan is directly connected to 24 volts, and that's why the fan is already running. I want to be able to control that by software, so that will be one of these channels. And the two other ones will be direction and PWM. Or do I need 2 direction pins? I'm not even sure. I have to check that, how to talk to that controller and be able to turn left or right, PWM for the speed, and an additional output for controlling the fan. So that's the electronics part that needs to be done.